So a quick overview of video standards. Digital TV, cine, I'm using the word cine instead of film. I use them interchangeably. The reason that, by the way, I do drop back and forth between cinema and film is because nowadays we don't use film at all. So when we talk about film, and you guys probably do this as well, right? You mean movies and other projects, but they're all video. So, but cine is just a way to differentiate them from the television style and maybe YouTube style videos. All right, some quick definitions. I know I promised you a word list. I've got one written. I haven't given it to you yet. Sorry about that. So here's a couple of words. Here's a glossary of what we're talking about today. The ATSC, the Advanced Television Standards Committee, this was the American committee that was put together to replace the NTSC, which was the old analog committee. And the ATSC's job was to develop digital television, or DTV, okay? That was the fancy term we used for digital TV back in the day to differentiate from analog TV, which was SD TV, all right? SD, by the way, eventually went digital. So SD is now used interchangeably for any 4:3 analog or digital television. Just standard def. You'll hear that expression. SDI is the serial digital interface. It's the blue cable you guys use in the studios to connect the cameras to the walls. And what that was a way to encode, right? So now serial digital uses a codec. It uses a 422 streaming codec, which was very low compression, very, very low compression. And in fact, let me think about it. No, SDI doesn't have compression. It only has color subsampling. It uses a single cable to transmit digital. HDMI, the cable you plug into your TV at home, that flat plug we've all seen. 2K is 2000. That's what the Ks are, thousands. And it's 2000 pixels in the screen's resolution, 1080 by 24 or 2048. Okay, 4K is 4000, and HDR, high dynamic range, that is a color space setting that is now being used more commonly to artificially increase saturation and contrast, but also widens the color space. So more data is required for HDR. And now we have this weird thing where people are referring to the regular television or regular video image as SDR, sort of standard dynamic range, but I'm not there yet. UHD, ultra high def. Now, ultra high def, is video 4K, as opposed to cinema 4K, also known as true 4K. And we'll talk about more of this later. Scaling. Scaling just means that you're going to resize images by enlarging or shrinking. All right. So when you see the term scaling, rescale, you're changing the image's size, not necessarily changing the resolution, just the actual physical size of the image. Sometimes the scaling changes the resolution, and we'll talk a little bit about that. So let's define high def, right? Pretty straightforward, right? No, it isn't. Because of the politics of the transition from standard definition to HD, there were a number, and still are a number, of competing high definition standards. The most common is that whole 720 versus 1080 battle. The history behind that was that 720 was a Panasonic. The company Panasonic was championing 720, and Sony and the others were championing 1080. So Panasonic pushed ahead, lobbied that 720 was in fact high definition, because technically it was higher definition than standard definition, but it's not as high as 1080. And nowadays we hardly ever use 720, except in the ways I was illustrating before. The reason that it was confusing is that before HD, there was only a single standard per country, basically. If you were an NTSC country, there was one set of rules for all of video and television, right? If you were a PAL country, there was one set of rules for you. And if you were a CCAM, which was a third type of format, there was one set of rules for you. And that was it. And we didn't have all this confusion that we sort of have today. So eventually NTSC, the old analog format, was maxed out. You couldn't make any changes. There was no ability to have 3D. You couldn't do a true widescreen 16:9 because of the standard limitation. There was no multi-channel audio. You could do stereo, but that was it. So you couldn't do surround. And it had lots of quality issues. So along came a change, right? We had to get rid of NTSC and go to digital. Okay. So the ATSC, created in the US, to coordinate digital technology. And I'll tell you why, again, politics being what they were, there was a global push to get a single high definition standard. I remember being around when this was discussed. And the United States had one company, I think his name was Zenith, that was still making televisions in the US. And that company lobbied the government that they needed to be protected. And therefore, America had to have its own digital standard using these American-made TVs. And the irony is that partway through the digital conversion process, that company went out of business, switched all their manufacturing to another country offshore, I think, or maybe Mexico, I'm not sure. And in the end, the reason for this whole separate American ATSC standard disappeared. But here we are today, still paying this world price, right? So you got the EBU, and I'm talking about the different competing standards. You've got the EBU, the European Broadcasting Union, and the ATSC. Now, the good news is, as the Americans have begun to realize that their manufacturing ability has disappeared, they're starting to come more in line with EBU. So we're hoping that one day when maybe we jump to 8K, that there is only a single standard, but we're not there yet. There's no reason, honestly, to have a different standard. Computers can now differentiate between 20 cycle power, 30 cycle power, or 25 cycle versus, no, start it again. They can differentiate between 50 cycle power and 60 cycle power. There's all kinds of things computers can do inside TVs. So we no longer need to have a separate standard, but we still have different standards. The thing with the ATSC, because it was flexible, it was a framework, not a standard. It meant there was more ability to have different ways to get to the target, but it also means more complexity, right? So what that means in the end is there's more confusion amongst consumers even now about what 4K is. Another example. So 4K, if you thought there was confusion between standard def and high def, one of the reasons we have two different kinds of 4K is, again, because there was no firm standard going forward into digital. So we have cinema, what's called cinema 4K or true 4K, and we have UHD, which is TV 4K. All right. So what happened? NTSC was renamed standard def. So there was no such thing as standard def before digital came in. It was just NTSC. It was then renamed to standard def, and then widescreen TV with the 720, 1080 resolutions was called HD. 4K is Ultra HD or UHD, and true 4K, which is actually 4K, is cinema 4K. All right. So by the way, marketing wise, the reason that 4K for televisions was referred to as UHD is because they felt the consumer understood high def. And if they ultra'd up high def, because otherwise 4K sounds like something different. The weird thing is it is something different, but they want to treat consumers like idiots and call it ultra high def, like it's the same, but only better. Right. And this, so what's frustrating for me as a professional is that this just causes confusion with your clients, right? And probably amongst yourselves. You see all these different terms bandied about and you're not even sure what's what anymore. There's no need for that. It's just marketing that drives me crazy. Let's just be honest, right? So what about 2K? Why do we have 2K? Well, theaters went kind of digital early because there's going to be a lot of money in the conversion from film projectors to digital cinema. And so they needed a format for projection that was ready, but wasn't that expensive. And what was ready was 2K. Because what is 2K? 2K is 1080 by 2048. So really 2K is just a slightly enhanced HD. So it'll shock you to know that a lot of theaters that you go to or went to back in the before times had only 2K projectors. So they had lower resolution than your home TV, or sorry, than your 4K TV. They had the same resolution as your home TV, slightly higher. So you'll notice that HD is 1080 by 1920 pixels. 2K is 1080 by 2048. Right? So the reason we have a different aspect ratio in 2K is because the height and width ratios of movie screens in theaters is not the same as it is in TVs, as is it in TV. It's the same as it is in televisions. So the theaters adapted to a 1080 by 2048, right? And that, by the way, the 2K HD split is where cinema and video formats began to diverge. Right. So 4K, what is 4K? Moving on. 4K is an image that's 4,000 pixels tall, right? Because it's 4 times the resolution of HD, and HD is 1080 pixels tall, right? Wrong. What they did, again, in marketing to make 4K sound bigger, better, and sexier than HD is they changed how we refer to the picture. Okay. And so instead of measuring the height, they started measuring the width because the number was bigger. Right. And when you're saying to yourself, what are you talking about? What I'm talking about is the fact that we refer to HD as 1080, right? 1080 HD. We always say that. Well, what's the 1080? It's the picture number of pixels in the height of an HD picture. But in 4K, we don't call 4K 2160, which is what it is in height. We call it 4K, which is the width, 4096. And that's only true 4K, by the way, because television 4K is only 3800 pixels wide, not 4096 pixels wide. Right? So which is, again, another bit of a wriggle why some manufacturers refer to TVs as UHD, because if they don't say 4K, you can't argue with them that they're claiming 4K resolution. They're claiming ultra high def. But we all know that ultra high def is video television 4K, 3840 by 2160. All right. But this causes confusion. Again, why didn't we standardize 4K at 4096 by 2160? Okay. And there's no good reason for that, in my humble opinion. I'm sure that people have all kinds of reasons, but there's no good reason for this confusion. So yeah, and I've just said that. So 4K, if you talked about the labeling conventions that we use, like 1080 HD, right? 4K is 2160. Well, it's really 2K. But 2K was already taken by the cinema people back here, right? When they developed 2K, which was also 1080 high, but it was wider. So they used 2K to describe it, right? Again, this caused confusion. People heard of 2K and they thought it was going to be 20 some odd pixels, 2000 pixels high instead of 1000 pixels high. But it wasn't, it was 2000 pixels wide. And that, again, that's where that diversion began from video and film standards. And so 4K is really 2K tall. But here we are in the world now of talking width. So we switched, just to be clear, we switched from talking about the width to the height to the width, and we're going to carry on that way with 4K and 8K. And the reason is, like I said, marketing and strategy. There's no technical reason to call it 4K. But is 4K twice the resolution of HD? It's got 2 times as many lines of pixels, right? So it's twice as good as 2160 versus 1080? No, it's better than that. There's 4 times, because remember, there's 2 times the number of pixels tall, but it's also 2 times the number of pixels across compared to HD. So 4K, 2 times 2 is 4. 4K has 4 times the resolution, but also, remember, 4 times the data of HD. So it's not a trivial thing to go to 4K, right? You're doubling it twice. Remember our binary lesson, the power of doubling. Well, doubling it twice, you're doubling everything twice to get to 4K, and therefore getting lots of data. Okay. It can bite you. All right. Cheesy, I know. Just a quick survey of some of the DTV formats, digital television formats. So we had HD, just to recap this, 1280 by 720. That's the Panasonic. These are all 16 by 9. They come in different frame rates. There's 1920, 1080, 16 by 9. It comes in more frame rates. So you'll notice that 720 by 1280 does not come in an interlace, right? So that's one of the other traps of Panasonic. Panasonic wanted to switch to progressive. Progressive frames are bigger. There's more data, right? Bigger bandwidth. So they sacrificed interlace in the 720 by 1280 standard. So what they referred to it as 720p, and you've probably heard this before. 720p. That's because 720 didn't have an I. There is no 720i. So if you're delivering to someone an interlace, you don't want to do a 720 resolution because it won't be compatible. 1920 1080 maintains interlace, right? For the reasons that we talked about with interlace, and it also has the different frame rates, the P and the I at 60 frames. 4K preserves the interlace as well in video format, 3840 by 2160. So these are all the numbers. And the reason this chart is here is just so you can have the numbers as a reference. So remembering that true 4K is, oh, here it is, sorry, is 4096 by 2160. That is actually 4K, sometimes called cinema 4K. It's an aspect ratio of 19 to 10, right? It's a slightly different size picture. It's a slightly wider picture. So it's not 16 by 9. It's a ratio of 19 to 10. All right. 8K is 16 by 9 again, and 8K is 7680. So we're actually getting further away from 8,000. 4K is actually a bit closer to 4,000 than 8K is to 8,000, but that's all right. For shorthand, it's 7680 by 4320. So we're doubling again. And the 16K is yet to be announced. There has been no standard yet determined for 16K, although it will be 16 by 9. And I just, by the way, that's note about the non-integer formats. I've taken out the 2997. So the interlaced, for example, a 60i would be 2997 or 5994, not 60. But remember, we talked about that before. When you talk about frame rates, sometimes you just round it to the nearest number. So it's always good to be clear when someone says they want something delivered at 30 frames. Do they mean 2997 or do they mean actual true 30? True 30 is very rare, so they probably mean 2997. All right. Just here's going to give you examples of the 5 different pixel densities of standard def, high def 720, high def 1080, ultra high def 4K, and true cinema 4K. And that's here in this slide. So you can see the relative screen sizes and sort of pixel densities, right? And what I mean is if you took that green square for HD and you could put it in 4 times inside that orange square of 4K. You could take the blue square of 720 and put it in 9 times, maybe, et cetera, et cetera. And you can see that the Cinema 4K, which is the yellow stripe on the side. So what this illustrates is the Cinema 4K is not just the yellow stripe on the side. It's all of the orange plus the yellow, right? So it's slightly wider. And DCI, by the way, is another term for Digital Cinema International Standard. You'll hear DCI. I don't like to use it because you're learning enough initials as it is, but it is a valid way to describe digital cinema, DCI. Okay, cool. So aspect ratio screen height to width, it's expressed in units. There is no measuring thing for aspect ratios, they're just units. And what that means is it doesn't matter what the actual dimensions of the screen are, feet, inches, meters, centimeters, miles, that isn't important. There's no measurement units. All you're doing is comparing the 2 sides in a ratio. So what that means is for every 4 units every 4 units wide, I've made a mistake there. For every 4 units wide by 3 units high, you have a 4:3 picture. In film, it's different. In film, we refer to the screen height as 1. So a film ratio is expressed with the 1 as the second number at all times. So 4:3 is, I think, 1.77 to 1, standard definition. HD is 2.33 to 1. And that means that in the first example with the 4 units to 3 units, so if you'd said it was 4 units, and that slide is really bugging me. Hang on a minute. Sorry, gang. I'm gonna have to edit this on the fly. It's 4 units wide by 3 units high. It's confusing me, and if it's confusing me, it's probably confusing you. There we go. Okay, back to current slide. That's better. So if your picture is 4 units wide by 3 units high, so 4 feet wide by 3 feet high, it's a 4:3 image. If it's 12 feet high by 16 feet wide, it's a 4:3 image, right? In the case of a film ratio, the height is whatever it is. If it's 12 feet, that's 1. And then the 2.33 is how many times wider than 12 is the picture. Okay, that's what that means by to 1. And why is it compared to 1? Because in movie theaters, when they keep changing screen sizes, you can almost never move the ceiling. You can often move the walls and there's room to make the screen wider, but in most theaters and throughout history, it's been very difficult to change the height of the room once you've built it. So movie theaters have agreed, and movie industry has agreed, that we're going to talk about the height of the screen as 1, and all aspects will be related to that 1. And what that means is that screen height in many movie theaters is the same, and as new formats come out, they just get wider. Okay, and they still meet the standard. So physically, the height of the screen is always going to be the height of the room, because you can't change the size of the room. That's the point there. All right, cinema aspect ratios, a few of them. CinemaScope, 2.35 to 1, ultra wide. 70 millimeter, 2.2 to 1. Widescreen TV, 16 by 9, 1.78 to 1. Sorry, there's the correct number, 1.78 to 1. And traditional TV, 4 by 3 is 1.33 to 1. So what that means, those last two, is if you want to express the television ratio in film numbers, if someone says, for example, you're talking to a film person, this will happen, and they'll say, I want you to deliver that to me in 178. And they often don't say the 1. They mean 16 by 9. 1.78 to 1 is 16 by 9. All right. TV standards were set to 16 by 9 because it was close to film standards. Digital standards will still support 4 by 3 with the letterboxing on the sides. And there's other aspect ratios in film than there are in television. Television has the 1 and the 2, 16 by 9 and 4 by 3. Here's some video aspect ratios compared to movie aspect ratios and screen sizes. So there was a rage, and I'm not sure if it's still going on, but a couple of years ago, manufacturers started developing 21 by 9 television, or pardon me, computer monitors, ultra wide monitors, probably for, I would doubt, for no doubt for gaming. So if you took a 21 by 9 image and played it on a 16 by 9 picture, you'd have those letterbox slots at the top. And on a 4 by 3 picture, you'd have even thicker ones, right? So this is just to show you what is, so the top row is 21 by 9 being displayed on different sizes of screens, different aspect ratios of screens, and then 16 by 9. So in the 16 by 9 example, the middle image fills the whole screen because it's the native resolution, aspect ratio, sorry, and the bottom, the 4 by 3 is the native aspect on the far right. All right. Conversions. So when you're changing screen sizes or scaling, you're up converting. If you're going to a higher format, so if you go from HD to 4K, that's considered an up conversion. If you're going from 4K down to HD, that's a down conversion. Okay. In either case, you're going to change the image size. You're going to change the quality. Okay. So conversions of any kind, up converting or down converting, will alter every pixel. And the reason is because when you change aspect ratios or resolutions, you move the pixels from where they were in the original image to a new location on the new screen. So every pixel has to be located now in a new location, and that relocating the pixel will alter it slightly. Because as you remember, with spatial compression, the pixels are all looking at their neighbors. And if you change the location of the neighbors or change the size of the neighborhood, then the spatial redundancy will change the formula and you'll alter each pixel. So the point of that is you don't want to down convert or up convert until the very end if possible, and do it the fewest number of times. Right? The more you do it, the more you damage the data. All right. You're still going to see bad aspect ratios. Here's an examples of bad aspect conversion. So what people often do is they'll take a 4:3 image, old school, and put it on a 16 by 9 frame, and then everybody looks fat. I see this all the time on TV still. More properly, in example B, you should put bars on either side. You can put colors or images in those bars. The funny thing about this is that when people use phone video that's shot vertically, they understand this. And you'll have a vertical rectangle in the middle of the phone video, and they'll put some bars on either side. But when they do a conversion of a full frame 4:3 image, they won't do it that way. And I don't understand that. The other way you can do it, though, if you want to make the image a bit more, the 4:3 image a bit more suitable, or you don't like the black bars, is you can zoom in on it. But as you can see on the bottom left-hand side now, the headroom's gone, and we've lost some information on the sides, right? And then the bottom right example is when you take an image that is wider than your aspect ratio of your monitor, and you squeeze it down to fit, you end up with bars on the top and bottom, and those are the letter boxes. So the top right, example B, is what's called pillar box because of the vertical pillars of black, and the bottom right, example D, is letter box because of the horizontal bars. All right, so some final thoughts to wrap it up because we're getting close to the end here. Digital TV standards are always evolving, as you know. This lesson will be different in a year or two, as it has been over the last couple of years. Every year I've got to add something and change something. HDR was the most recent addition. 3D and VR, virtual reality, was dropped. And that's because 3D TVs flopped. I have one. I'm actually looking at it right now, and I never bought the glasses because it was a complete waste of time because nobody made any decent 3D movies for the home, and as a result, the whole thing died. There'll be a change in quality. or some other effort to boost TV sales. So what I'm saying about that is, and this is my kind of cynical consumer comment to you guys, and I'm in the market right now actually for a television personally myself. There's lots of things that are out there to push you to buy a TV. And you'll find that, for example, QLED or QLED is a buzzword now that is being used to push LED TVs, because OLED, organic LEDs, are making inroads because of their higher quality and contrast ratio. OLEDs have a weakness about brightness. Like, for example, OLED TVs don't look that great in a bright room, but it's no coincidence that the other LED, sort of standard LED TV, has been tweaked. Samsung, I think, is the one that, or hang on, is it Samsung or LG? Might be LG. Anyway, doesn't matter who. I'm not trying to tar anybody with this, but they've picked a letter, Q, that looks a lot like the letter O. So when someone's out there looking for an OLED and they see this Q and they think, oh, Q, there's a couple of round letters. And I'm not kidding you, right? People make decisions on some of the goofiest ideas that there's now going to be a bit of confusion. Oh, is QLED better than OLED? Well, QLED is just traditional LEDs. OLED is the organic LEDs. They're totally different. QLED and regular LEDs aren't that different, but you think they are because they've added that extra letter. So marketing is always out there trying to take money out of your, I was going to say your wallet, but take money out of your phone or out of your app and into theirs, right? The next big thing is at HDR. Who knows? We'll find out. Mobile TV viewing may break this cycle or continue it, right? Phones are being constantly tweaked to show images more easily and better. 5G is one big push to get better streaming images on phones, because the phone manufacturers realize that, so just to give you a quick background there, phone voice communication technology on phones has stopped developing because phone manufacturers moved on. That's not selling phones. So then it was texting apps, computer programming to make your phone more of a small computer in your pocket. Well, now it's streaming, right? And they're, because they need to sell more phones. I just bought a new iPhone this last fall, and I'm very disappointed in it. I have a phone that's 5 generations older than my current phone that works just fine. The battery was fading on me, and I thought, oh, I'll get the new phone. You know what? I'm not impressed. I'll be honest. Anyway, it's marketing. I should have kept my old phone and I put a battery in it, but you get nervous. It's FOMO, right? Nobody wants that. And then there's VR. Is VR going to happen? We keep hearing about it. They keep pushing to make it work. Not working. So there you go. There is